So the starting point to understand about carboxylic acids is to know that they're an organic molecule that have a carboxyl group. A carboxyl group is a carbon that's double bonded to an oxygen and single bonded to another oxygen and a hydrogen. The carboxylic acids have an R that refers to the rest of the molecule, and these are found in amino acids. And we also need to know that carboxylic acids have some derivatives that we're going to be learning a lot about in this video. There's amides, nitriles, esters, acyl chlorides, and hydrides. And so one thing that you'll see with the amides is that there's some similarity to carboxylic acids with the double bond to an oxygen, but instead of an OH single bonded to the carbon, there's an NH. And like the carboxylic acid, they also have an R group. Nitriles, on the other hand, are quite a bit different. They have a carbon that's triple bonded to a nitrogen and single bonded to an R group. So those are quite easy to pick out, as you can imagine, because they have a triple bond, and that makes them stand out. One easy way to remember the ester groups is that they have two R's, and one of the R's replaces the H on the OH that was in carboxylic acid. And as a matter of fact, that's the only difference between a carboxylic acid and an ester, is that the H gets replaced with an R group. Acyl chlorides are very easy to remember. Just remember, chloride has a chlorine, and the carbon is double bonded to an oxygen. And so basically think of a carboxylic acid with the OH removed and replace it with a chlorine. And the last one we're going to do is the anhydride. So think of an as meaning not, hydride referring to hydrogen. So this one has no hydrogen. And it actually has kind of like what looks like a mirror image appearance, and it's got two double bonded oxygens to two carbons and two R's. So one of the distinctions that we're going to make in this video is we're going to talk about how to name molecules with common names or IUPAC names. Sometimes they're the same thing. Sometimes the common name is also the IUPAC name, but sometimes they're not. But we won't get into that too much in this video. So when you're using common names for carboxylic acids, the first step is count your carbons, and that will be very helpful to you. And the second step is to remember the mnemonic. Now we're going to do a lot of mnemonics in this video. So the mnemonic for common names of carboxylic acids is, for any naming of carboxylic acids, please be very careful. So the first one we'll do is formica. That's one carbon. So, for example, formic acid, which is used by humans as a food preservative. It's used by ants as a toxin. And its IUPAC name is methanoic acid. Then we have two carbons as acetum, such as acetic acid, which is found in vinegar. And its IUPAC name is ethanoic acid. Three carbons is propionic. Propionic acid smells like BO, and its IUPAC name is propanoic acid. With four carbons, we have butyrum. Butyric acid is found in rancid butter. Its IUPAC name is butanoic acid. Five carbons is valeric. Valeric acid is found in the foul-smelling plant valerian. Its IUPAC name is pentanoic acid. And then finally, caproic, that's six carbons. Caproic comes from the Latin word for goat because people notice that it smells like barnyard animals. And its IUPAC name is hexanoic acid. And so it's also important to note here that there's also IUPAC prefixes for all these numbers of carbons, and that's 1 is meth, 2 is eth, 3 is prop, 4 is bute, 5 is pent, and 6 is hex. So what should we do if we have a carboxylic acid that's got 2 carboxylic acids in it? How would we name those? Well, those are known as dicarboxylic acids, and there's a separate group of prefixes for those. And just remember this mnemonic for these. Oh my, such good acids. So 2 carbons is oxalic acid, which you can find in many plants and vegetables, and it's frequently used as a reducing agent. Its IUPAC name is ethane dioic acid. 3 carbons is malonic acid. It's found in some fruits, and it's actually named after the Greek word for apple. IUPAC is propane dioic. Succinic acid is for 4 carbons, and this is involved in inflammation. It's also used as a food additive. Its IUPAC name is butane dioic acid. 5 carbons is glutaric acid, and your body naturally produces this type of molecule, and it may cause irritation to the skin and eyes in a laboratory setting. IUPAC name is pentane dioic acid. And the last one is the adipic acid with 6 carbons. This is considered to be the most important dicarboxylic acid. And the reason for that is they use it to make a lot of very popular products like nylon and polyvinyl chloride that they would put in like plumbing pipes. IUPAC name for this one is hexane dioic acid. And there's many more, but for the purposes of this video, we'll just go up to 6 carbons. So at this point, you have a pretty good understanding of the prefixes that are used with carboxylic acids and their derivatives. So let's take a few minutes and talk about the suffixes that you would use. So the first one is for carboxylic acid itself. In this one, you drop the final E and replace it with oic acid. So for example, the hydrocarbon hexane would become hexanoic acid. Carboxylite salts, we would replace the oic acid with the suffix ate. So benzoic acid, for example, would become sodium benzoate. In esters, you use the suffixes either ate or oate, as in the molecule ethyl acetate. Carboxylic anhydrides, in these you drop the word acid and replace it with the word anhydride. So that's fairly straightforward. And so, like for example, acetic acid becomes acetic anhydride. Acyl chlorides, you drop the suffix ic acid and replace it with aryl chloride. So another pretty straightforward naming rule there. Propanoic acid becomes propanoyl chloride. Amides, again, drop the ic acid and replace it with the word amide. Acetic acid would become acetamide. And finally, nitriles, these you just add the word nitrile to the end of the hydrocarbon. So the hydrocarbon ethane, for example, would become ethane nitrile. So at this point in the video, let's go ahead and test your knowledge and see how much information you've retained. So make sure after you see each molecule on the screen, press the pause button so that you have a chance to work it out. So first of all, you ought to know by now that every time you see a COOH, that is a carboxylic acid. And then after that, all you really have to do with this one is count the carbons you can see that there's 6. The easy way to remember this one is this mirror image looking molecule is an anhydride, and then count the carbons on one side of the oxygen, and you'll see it's acetic anhydride. So the first thing you probably noticed is that this ends with the suffix "ate," which indicates it's an ester. The right side of the molecule is 2 carbons, which is known as ethyl, and on the left is the acetate. So first of all, you can see there is a carboxylic acid here, COOH, and there's actually 5 carbons, which is valeric, so clearly valeric acid. And this one is probably the easiest one, in my opinion, out of these 6, because it's simply 4 carbons, and then you'll see one of the carbons is triple bonded to a nitrogen. And every time you see that triple bond, you'll know to add the word nitrile.